So before starting the session, may I know how many filmmakers are here? Filmmakers. Great. Yeah. And may I know how many are into VFX? VFX. Great. For the title, it's about Cinematographer's Guide to Virtual Production. But it's absolutely knowledgeable session for all craftsmen who are working under VFX, editing, post-production, and on the production stage, like it can be a director and also cinematographer and production designer as well. But today's session is crafted in such a way, anyone who wanted to step into virtual production as a beginner, this would be a perfectly like a proper session to attend and to know about virtual production. From here on, you can absolutely move forward and you can Google and you can read your documents, and also there will be a lot of forums available and a lot of videos available in YouTube as well. So this is the setup that we have in Annapurna, which we call it as Anna Virtual Production Stage. Basically, what is virtual production? It's a simple form of latest VFX scenario where you will be mixing your traditional shoot or traditional actors along with your CG generated images. We can put it in short. That's what is virtual production is about. In virtual production, we have the first breed of virtual production is Chroma virtual production. So many of you, I believe, how many of you heard about virtual production? Awesome. So I think from the post-COVID situation, we've been hearing about virtual production more, right? So when they started virtual production, there is a lot of confusion between what is Chroma virtual production and what is LED virtual production. In a simpler form, Chroma virtual production, it's absolutely the same way where we used to shoot our regular VFX content. How many of you worked with Chroma before? Right. So anyone who worked with Chroma before, it's the linear workflow is like we shoot something against Chroma, go to post, remove the Chroma, right, and submit your final output. But that takes time for post production, right? And the real-time Chroma virtual production is like a little advancement to your regular Chroma workflow. This is like where you will be shooting in real time and you will be also able to see the output in real time. Why? Because it is equipped in such a way, that particular Chroma flow, where you will be able to shoot against Chroma, and I think you can see in the monitor here, whatever they are shooting, the director will be able to make his judgment on the spot itself, how his Chroma is getting removed, as well as in which environment you are able to place your actors. So that's about Chroma virtual production. Now there is a second type of virtual production which is called LED virtual production. The full form of it is called ICV, the shortest form of the technology is called ICVFX. The full form of ICVFX is in-camera visual effects. Alright, so this is like more advanced than your regular Chroma virtual production, where you will be, instead of shooting your traditional shoot against Chroma, you will be shooting against the LED one. Okay, so in this particular ICVFX, today I'm going to introduce you to some technical aspects. Anyone who wanted to approach virtual production in LED world, what are the things that a technical person should know? It can be a scriptwriter, it can be a director, it can be a producer, it can be a cinematographer as well. So that's what is in short ICVFX means, which is called in-camera VFX. Now, as I am mentioning about it, technical aspect that a cinematographer should know. The first one, 3D versus 2D. So many of you might be, people who are into VFX, definitely they will understand what is 3D, because we will be having X, Y, and what is the third one? Space, Z. So X, Y, Z. So you will be working around 3D, but it's not actually a 3D, stereoscopic 3D that we watch in theaters, because you will be having a one more space to travel in your environment. That's what you actually mean by 3D environment. And 2D is something, a baked footage. It can be an image also. And the second one is LED pixel pitch, moire, and focus and depth of field for cinematographers. How to manage when you're working in LED virtual production scenario. And you have camera and lens choices. I think many of you have this doubt, like what cameras I should choose for virtual production, what lenses I should choose for virtual production. And then we have one more topic about frame rate, because there is a lot of confusion between what frame rate works and what frame rate doesn't work. And then we have Genlock and Unreal Engine and VAD. Don't worry, the full form of VAD is Virtual Art Department. They are the same people like visual effect artists, but the visual effect artists, when they're working in Unreal environment and Blender, they are meant to be called as VAD, Virtual Art Department. And lastly, you have photogrammetry and camera tracking and lens calibration. So how many of you are aware of camera tracking? Great, awesome. So let's skip to the first part, 3D versus 2D. Before knowing about 3D versus 2D, parallax. Parallax is something, it's a technical aspect. Especially most of the VFX artists will be easily understanding this particular concept of parallax. Instead of going through the theory, I'll tell you a simple example what is parallax. Imagine you're traveling in a train and you're seeing from a window, right? How many of you observe that the current poles are traveling faster than the longer distance hills or trees? You guys have observed any time when you are traveling in the train? So you can see that the closer objects move faster and the farther objects move slower, right? So the differentiation, the momentum between the closer and the farthest object is called parallax. So the way to create this is to, so I'll show you a small example also. So this is an example for no parallax. I think you are able to see everything is moving like just like a slideshow. Alright, there is no depth in it. So if you want to create depth, then you have to definitely opt for 3D environment. So something like this with parallax, you are able to see the foreground is being, it is moving at one acceleration speed, and the farther clouds and hills are moving at one speed. And play again. So sorry. Yeah. So that's the best example for parallax that I can give. So what I'm saying is when you opt for 3D or else 2D, so this is what you will be losing if you're shooting with a 2D plate. But you can also shoot with a 2D plate if at all, if it is just like a one-liners or something which you're shooting against LED. But if it is like a proper shot which you actually require momentum and proper depth, you need to opt for 3D environment. And how many Unreal Engine artists are there here? Anyone who are in touch with Unreal? And Blender? Yeah, we can see some Blender people here. So you guys will be knowing this more in a more better way. Then, so 3D asset. So as I'm saying, there will be depth in that. So this is how a 3D asset will be there. So because you will be able to control everything, you will be able to control each and every element or every property in the 3D environment. This is like a parliament sector. And you will be able to block it anywhere. Like you can actually, in short, I can say like you can operate it like a game. Alright, so you can actually go inside wherever you want and you can place your camera there. So this is what is called a Unreal Engine asset building. So as you can see, I mentioned it as VAD, which is called Virtual Art Department. So they are the team who builds these assets. So this is like small GIF about how you can control each and every element if it is a 3D environment. But if it is a 2D shoot, you will not be able to control anything. Whatever you are getting, you shoot somewhere, you shoot some footage, you get it and play it on the LED. Next we have 2D driving plates. So this is like a quite one good example about driving plates, because we just mount the camera to vehicle and wherever you want the location to be shot, you go there, shoot it and get it back to your studio, LED stage, and play it here. And before even this is a LED, I can play a driving plate here and I can place a bike over here or else a car and shoot. So that's a simpler form of approaching for a 2D shoot. I can show you one example for this. I don't want to bore you much. Right, so. driving plate now. So basically, we'll if you can see in the image, there is it's the same car. We have surrounded and we have mounted 9 cameras to it, 8 cameras, sorry. So total of 8 cameras in different directions. The advantage, you might be asking me like, will one camera is not enough? But it's not about that. We want to create a library which will be helpful for any filmmaker. So he cannot, maybe this is like a Bandipura forest area. So if someone asks for a dense forest roads, we will be providing this and we will be showing this to director as like the 9 cameras. He can select which angle he wants. The filmmaker can select which angle he wants. So that's the reason for providing all the 9 cameras. And you also have one more option, making it as a 360-degree stitch. Yes. So many of the people who are working in After Effects or anyone who will be comping it as a 360 stitch and then put it on LED, so that we can pan around and we can just rotate the car to the side profile, rotate the footage and shoot. That's the whole solution of doing a driving plates. Now the second foremost thing, LED pixel pitch, right? How many of you heard about LED pixel pitch? So let's make it interactive. I don't want to bore you much. That's why I'm asking. So it's not a lecture. So you can actually treat this as a guidance. So let me know how many people are aware of pixel pitch, LEDs. All right. So basically LED, even this LED is also made of tiny pixels. Okay. And any LED in overall the worldwide, it is measured in pixel pitch. So the pixel pitch is nothing but difference between the distance between each pixel to pixel in one particular cabinet. All right. And we have you can see there, that's a 2.5 pixel pitch, which means the distance between pixel to pixel is 2.5 millimeter. And here you can see there is a pixel pitch 4 You can observe the distance is more than between when you compare with 2.5, this is the distance is more between both the pixels. So that's what is called 4 So 4 is nothing but in events, I think you guys are aware of P4. Yes, P4, P3 LEDs. So that's what P4 means. But in filmmaking, particularly for virtual production, there is this formula. Anything which is up to 2.36 pixel pitch and below can be used for filmmaking because of its richest quality. So how quality differs now? You can see here, I gave you a finer pixel pitch, which means 2.6 and below, like 2.5, 2.4, 2.3. Now even Sony came up with a crystal LED, which is also 0.9 which is like ultimate. Even if you go like 1 feet also, like half feet from the LED wall also, you will not be observing any pixel variation in it. No crankiness. That's called CLED. In the same way, Samsung also came up with OLED. So you have different LEDs now in the industry. And currently the LED era is going on. Even the theaters are shifting to LEDs. Okay. So the finer pixel pitch, which will be giving you higher pixel density, which means that since the distance is less, you will have more pixels in cabinet. So obviously you will have highest resolution. And in the same way, larger pixel pitch, you will have lesser number of pixels and you will be having lower resolution. So that's a small brief about pixel pitch. Now you have moire. How many of you have seen this kind of pattern when you try to capture TV? TVs, mobiles, great. Even if you are shooting, planning to capture something on your laptop, you might be noticing this. So I'll tell you why it is happening. This technical term, this is called moire, but also it is called as moire. So now what is moire? So moire happens because, as I told you, even this LED, if you notice, maybe you can see from this distance, I am able to observe all the pixels, right? The continuous repetitive pixels is creating a pattern, all right? And your sensors, it can be a mobile phone, it can be a digital camera or film camera. A sensor is made up of thousands of photosites. Even photosites are also pixels for the sensor, right? Even that will be creating a pattern. So when that pattern interacts with this particular LED pattern, the moire appears. All right. So that's how the moire actually gets created. So I will also be telling you how you can come over and escape from this moire. So there will be three factors. Imagine I am the actor and there is a camera which is shooting me. Okay. I think if I am standing more near to the wall and
the cameraman is focusing me, Moir will be there definitely, because me and the LED wall falling in the same focal plane. All right. To escape this, the only instruction that we need to give actor and to the director during the shoot is like, I'll be telling him, please don't go so close to the LED. Please maintain 10 feet distance minimum, or else 5 feet distance. Depends on the pixel pitch. There is a chart which actually tells you which is the best minimum distance to maintain. Okay, and the second one is maximum focus distance. So if the artist, if now the photographer is planning to shoot me, and I'm also from I think 12 feet away from this LED, and if he is planning to shoot me with 12 mm, Moir might be there. But if he's shooting with higher focal length, Moir won't be there because of depth of field. All right. So it's always you have to play between your actor's position, your LED position, and the placement of the camera. All right. Now camera lens choice and frame rate. Cameras, it's very clean. You can either opt for full frame cameras, or you can also opt for S35 sensor models, no problem. But any camera that you are approaching, it should be having something called Genlock. So I won't go much depth into Genlock. I'll tell you a small input about Genlock is, so I have an image. Okay, you can see this particular small device, right? So this is called Genlock. So what it does, it will, when you connect all your digital devices in a virtual production floor, it will sync all the devices together, including LED, LED processor, Unreal Engine, camera, even the frame rate, and the even LED processors. So this is what it does. So Genlock is mandatory. Otherwise, you might face different issues while shooting. So coming back, so that's where Genlock is mandatory. And you have an example, that's a Sony Venice 2 here, and this is a Alexa S35. In some of the cameras, the Genlock port will be mentioned as sync in. Okay, and in some of the cameras, it will be mentioned as Genlock. Straight away, it will be written as Genlock. Here, this port. All right, so you can actually search in any of the camera's data in Google. You can just Google it. It will tell you whether that particular camera has a Genlock or not. So this is very important. Okay, and now coming back, now lenses. No doubt about it, you can either opt for spherical lenses, or you can also go for anamorphic lenses. So no problem at all. And next, frame rate. Currently, the cameras are there, like even it gives 240 fps normal cameras. And definitely one thing I would like to say, which I didn't mention in the PPT, is you can't shoot with phantom cameras, because it gives you 960 fps and 1000 fps. Impossible right now, but I don't know, in future definitely it will be possible. The maximum that LED is made for cinema and LED is made for film industry, for filmmaking and virtual production, currently LEDs are capable up to projecting 120 fps. But whether we can shoot in real time or not, that's a question, depending on your computing power, depending on your render engines. I think most of the VFX people will be knowing, like, to run one Unreal asset, how long it will be taking, and also to render out after your shot making. So it's a very tough thing to manage those many render nodes and GPUs. So it's about that. If you are giving lot of push, lot of computing power, and LEDs are capable up to 120 fps, yes, you can shoot up to 120 fps. But when it comes to our stage, we are currently, the width, I showed you the image of our stage, that's the 60 feet by 20 feet wall that we have. It's a very big wall. So that we are allowing, with whatever render nodes that we have, we are capable up to 48 fps. So in our stage, I can push up to 48. But we also give the client another option. If you let us make the wall smaller, you can shoot 120, which means I can cover like 30 feet by 15 feet for those particular shots. In backside, in the back end, what we are actually doing, we are pushing all the computing power to only one particular section of LED. So you will be able to shoot 120 fps. In Genlock, I think I've shown you. Now photogrammetry. How many of you know photogrammetry? Great, super. So photogrammetry is a simple thing. I showed you the Unreal Engine asset, right? Imagine in front of Parliament, out of like it can be a fictional. If you really require this kind of fountain, or else some placement, some property to be placed, and but you have it in your garden, and you can't actually get that to studio for scanning, right? And what we actually do in photogrammetry is there is different approaches, different softwares that help you to get photogrammetry done. You will take your cameras. It's a simple process of capturing multiple images of that particular product or property, right? It can be 200 images, it can be 300 images from different angles, and then stitch it in a software. There are multiple softwares to do this. It will stitch everything together and it will be giving you like a 3D model. And how many are 3D artists here? No 3D artists. So any 3D artist, once you have the mesh and once you have it with the texture, you can directly place in the Unreal asset. So that's what photogrammetry is about. And then camera tracking. So you can see there is a small attachment which is attached on top of camera here in this image. And in this image, you have a small square box here. So that's tracker. So what does this tracker do? In Unreal environment, when you're putting some image on LED wall, you will be having a virtual camera, right? And on the ground, like this one, we have a physical camera. But if I am moving my physical camera, and if you wanted the virtual camera also to mimic the same movement, you need this tracker. So basically, what does this tracker is doing? It is acting as a bridge between your physical camera and virtual camera. So what it does, it will mimic the every movement, even a small 1 degree movement, it will capture, it will send it to Unreal Engine. So in asset also, the same movement will be created with the parallax. Let's see a video here, so you will understand what is a tracker does. Hope you understood, right? So I can just show you like on the thumbnails here. My cameraman is actually moving the camera in front of LED wall, and you can observe that blue box is also following my camera, right? So that's happening because my tracker is communicating with Unreal Engine. All right. So when I move my camera, the blue box is also moving. Blue box is nothing but a frustum. So that's a technical term for it, which means you can consider it as the blue box is nothing but your field of view of that particular lens. Okay. So when you move your camera, so this is my tracker information. Even this tracker information you are able to see when I'm moving, the trackers are also moving, right? It is able to track the geographical location of camera. And on the third window, we have Unreal Engine. Here there is a virtual camera here. That's the virtual camera in Unreal. As I'm moving my physical camera, my tracker, because of the tracker, my virtual camera is also moving. And then this is the final output, inner camera. Because this basically Unreal people who are using will be understanding that viewport and inner camera. So in viewport, you will be able to see how it is reacting. And this is the inner camera, how the final output is moving on the wall. So that's about camera tracking system. And there is I just included these two because this is what we are using on our floor. And this is a product by 𝐕𝐢𝐫𝐭𝐮𝐚𝐥. It's called Cincraft Scenario. And you also have a lot of other trackers also. Like Sony has recently launched Oscillus. That is also a product, object-based tracker. So you have a lot of trackers in the market. Then let's so those are the main aspects to to get your first step to virtual production. And this is a simpler workflow. So this is very interesting, like with examples, so you'll easily understand. So any client who is walking in should come with a story or idea or a storyboard or short division. Then a simpler form of short division would look like this. Now you understood about 3D asset, right? So you understood about 3D asset or not? Yes. So yeah, Once the 3D asset is done and once the DOP is sitting for the pre-visualization, so this is our a small example for pre-visualization. So what are the steps will be there in pre-visualization is basic scene layout, which means that's a station basically. The station is prepped with whatever basic lighting, and next camera you can block. Like my first shot would be the straight follow shot of the person, and my second shot can be the static shot of person passing, and the third shot will be the track again. So this is our previs is done. And next you have small example. This is also a recent previs that we have done. So I showed you an indoor, and this is like an outdoor one. So you can even create not only images, you can also create video lengths, so that director will understand easily like how much length each shot is coming and what is the dialogue that he can patch it. Then you have Techvis here. Tech visualization, the full form of Techvis. So in tech visualization, you have camera and lens decisions made by DOP, and physical prop visualization. Physical prop visualization is nothing but like you can see on stage there is lot of plants, sand and rocks. So these will be provided by production designer. So that's what it is about. And on stage 3D layout is belongs to WAD team, and you have tech details. Even if you see, this is the final shot that how we want. This is how we will be capturing it on stage. So this is about technical decision making stage. You can opt which lens to be used, and to achieve this movement, either DOP requires a crane or a jimmy jib or else a dolly, track and trolley. So what equipment he wanted to choose. So this is the decisions you can take in tech visualization. And next you have, this is one more example for tech visualization. As you can see the final output here, sorry, and the camera is almost traveling from 20 feet to 50 feet. Only then you will be able to get this final output. So because of Unreal Engine, you will be able to understand exactly how you can achieve each shot. Then final asset creation. So this is the stage. You might be seeing a basic asset, but with DOP's inputs, you can the DOP's inputs you need to give to VAD department, virtual art department, who are working in Blender and Unreal Engine. Once it is done, they can get whatever lighting you want with final textures and final shadows. A small video about it. Yeah, as you can see, there is a same shot, same environment, but you are able to see with different lighting conditions. Exactly. So this is the flexibility that you have either in Blender or Unreal Engine. That's why I mostly design our assets in Unreal Engine, because of the flexibility. But no doubt you can also get your Blender file. So this is how you can modulate your lighting and keep it as a presets. So on the shoot day, we can change it immediately. Next, the production stage. I think you have seen it here. I showed you like a simpler workflow. Now we are done with concept, WAD, pre-production. Now we are in the production stage. So in the production stage, you have, these are the some steps that it will be involved. So to understand better, lens calibration, type ceiling mapping and color calibration is something that we take care. DOP or film crew who are from the client side is not absolutely not required, but the decisions should be done. DOP needs to tell us clearly what camera he is planning to use and what lenses he is planning to use. Okay. So once it is done, we will be taking care of it. In the same way, OCIO calibration. So it's basically a color calibration. How many graphic designers here? Or people who actually work with true colors, who wanted to work with true colors? Right. So you guys know better how color calibration is very important. So in color calibration, it's a simple technique. We play something on the LED that we are planning to shoot. We record with our camera. We analyze both clips in a software. It will give you a 3D LUT. So we will just input that 3D LUT in our processes. That's the simplest explanation of color calibration. And why it is required? In the earlier stage, we have done the final lighting. You have a very reddish, pinkish sunset condition. But once if we don't do color calibration on the shoot day, it will be cranked because you will be getting false colors. Your pink won't look pink, your red won't look red if you don't do the color calibration. That's why this stage is also very important. So I would like to play a video about lens calibration just to get you an idea of processing, how it is done. Check. That's the tracker there. So I'm working with my associate, and that's the software that comes with. So you can ask me like what we actually do in the lens calibration. So we will be having different lenses, right? 25 mm, 50 mm, 85 mm. So we will actually store. I told you about tracker. We will store all lens data. We will make sure my tracker remembers it. When we are changing lenses, 25 mm will have particular distortion. 80 mm will have different distortion, and also the concaveness and the field of view. All the lens data, we through a software will load it to the tracker, so it remembers and gives you the same feel when you change your lenses. And also this is the main key step to produce that blue box that you saw earlier. So that blue box on the screen, frustum. So this is achieved only after doing a proper lens calibration. And also one more video about color calibration, just to get you a glimpse about it. Okay, so that's about lens calibration, color calibration. Then we have the final shoot day. Now the production, actually we call it as tech check or mock shoot. I'll tell you why we call it as mock shoot. So if we have a very big star that we are planning to shoot with, you can imagine he's a very big star and very difficult to get his date. We can't actually call him for test shoot and waste his time, and we can't waste his call sheet by doing our tests. So that's why whatever project that you're doing in virtual production, please consider one day before as a tech check day. So this is main reason is because you will be checking different aspects which is mentioned on the wall on top. Asset check on wall, what all the Blender files or Unreal files that you have worked. So that will be checked each shot by shot. And then virtual and asset, physical asset matching. I told you, I think in this image you are able to see that's an antique shop, antique element interior. And in real time, we definitely need to match it along with real properties. So if you can see, this is how the placement will be done with all the real table, real properties, and remaining extension will be on the wall, which means whatever interactive elements is there with your actor, that property should be real. And who will get this? Production designer or art director. So they will be getting all these according to the list that we give, and we will be placing it in front of the wall. And you also do your basic on-set lighting to understand. And next you have on the shoot day, this is a small glimpse example how after blending the real properties and the wall, this is how the final look will be there. You will not be able to say till which part it is real and which part is LED. Got it? That's what is mainly the cinematographer lighting also plays a key role in blending. So that's why he should be there for digital lighting as well as he should be there for physical lighting. And this is one more frame that we are able to see, like with the artist long shot. So this video is with all the shoots that we have done till now. You will be able to see some BTS shots, some the final shots. So you will understand with all complexes that we have achieved. So yeah, that's how we do shoots on the stage. I think you got some answers, right? How we are actually blending it with real properties. So there is a formula in virtual production. You always have to consider it in three levels. Treat your LED as a background. Okay. Treat your actor as your foreground, and please fill your middle ground. So do not leave it empty. If you wanted like absolute blend with your physical properties and with your digital asset, definitely you need to fill it up with your as many as properties as possible. Only then you will be able to achieve hyper realistic. So this is one more example where you are able to see there is a LED wall behind, right? And there is a prop like a balcony or of a sky high hotel, and these are the final shots that we got from that shoot. So we can see Katrina Kaif is just standing and looking at the city view from her window, right? So this is how it will be done. So that's why production designer also plays a very key role in providing the set elements and real property elements to us. And this is one more output that you are able to see. I'll also show you the BTS in it. So to achieve basically the entire desert with the sand dunes is actually on the wall, and you got perfect hair blend and you got perfect lighting done, and this is how it is done actually. Got it? So you have the actor there, and you have a small sand dunes and real sand that is placed, and you also have a desert asset in the background. So, and you can see cinematography people, you are able to see in digital asset, I have a strong key light from right side of the frame. So that's why I also placed a physically strong light on the right side, right? As you can see from there. So only then you will be getting the proper blend like this. This is like a one more VFX shot. So this is like a one input. Not every shot production designer can provide same pillar that we ask for. We can actually place dummy pillar like this. Later on, we can also again send it to post production so that the pillar will be replaced with whatever 3D element that we give. All right. So this is like a just one example to it, and that's the end of the workflow as well. So before ending it, the cinematographer, where all he is actually to be involved. Like we need him during the asset building stage, we need him in the pre-visualization stage, Techvis as well, art department inputs, lensing and camera choices, and lighting strategies and lighting integration. Now, please, any questions, please? Anyone, feel free to ask. I know that's a lot of information. Please. You can shoot minimum 60 FPS footage to have it in hand, so that you won't lose. If at all if it needs to be slowed down in post, also you will be having extra frames. Mocobot, it's better to maintain 48 to Mocobot as well as camera. Should be same. Should be same. Footage can be whatever you want. You will then downsize it to 48 FPS. This is like a one advice. It won't match, sir. It won't match. Then your real acting person will look fine, but the backside it looks smooth. That's why the frame rate of the plate that you get and frame rate that you are recording has to be decided priorly before the shoot. So that's why, like during my presentation, I told you digital lighting. So whenever the main first step should be digital lighting, and DOP has to match his physical light also according to the same light axis. Only then it will blend. Yeah, because many people, that's what they're thinking. Just place your actor in front of LED and do the shoot. But no. So this session is about that, to guide the cinematographers about how to approach towards the lighting. Where night lighting is very crucial. Why? Because there will be a lot of shadows in night asset, right? Which means darker areas. And there will be, even right now, if you see, there is a lot of spill which is falling on the LED. The only way to do is you ask your DP, get a proper DP who is really crafted for virtual production shoots, so that he will make sure the lighting is not getting spilled by using flags, by using cutters, and avoid the light spill on that. So for knowing this, what we generally do after lighting is set, once we will ask our Unreal Engine supervisor to switch off the display, so that I will understand how much blackness is there. Is there any light again leaking on the wall? So that I will just go do the fine tune. As you can see, but if you are using polarizer only for avoiding reflections, use the lesser dense polarizers, because you might be having tone shift in the final out. So it's better to use lower ones, because not also NDs. If you use too many NDs, it will be really hard. I'll tell you two things with the NDs and polarizers using in virtual production. If you're using too many filters, you need to pump your lights more. You will get more spill on the wall also. Try to use LED ceiling, and like in my, you can see our setup, right? Like this. Try to make your lighting first with the side wings and dolly itself, and the ceiling itself. Then calculate your physical requirements of the light. Okay. And you also need to definitely use lot of honeycombs, lot of flags. Even I put bigger 20 feet T rods. I prepare 20 feet T rods or 12 feet T rods for cutting. Yes, it matters. Yes, it matters. But by default, our nits always will be 2000. But constant of white color. What we generally do is, after switching on our wall on the day, we put white, switch it to 2000 nits. Now, when you load your asset, you generally have exposure values in it, like one stop down, one stop up, whatever you want, we can do. Yes, absolutely. All color, saturation, every parameter you can control from Unreal Engine. All right. So that I can conclude our session, the end of our session, and you guys can follow our YouTube channel page. you have lot of case studies, you have lot of making videos and outputs also in that channel. And anyone have any queries, you can actually mail us there in the mentioned mail IDs. Thank you very much.